thank you everyone for joining in and spending your time on this webinar. I hope it is most pleasant for you and that you can learn something out of it. So that you know who you are talking to. I'm the product owner of the service ETAS Data Insights, which is part of the ETAS Pantares portfolio. And I want to briefly introduce you to the service so that you have the same background information, the same base, so that you know of what I'm trying to show you and what I'm trying to provide you of information. Therefore, I would like to introduce you our managed cloud service Data Insights. And yeah, first, you might think, oh crap, just another cloud service. I heard them all already. What's the difference? I've seen so many. Yes, you're totally right. It's totally understandable. And there are a lot of services out there, and nowadays, especially the market. But I really hope that I can show you a difference and something new today. So first of all, what does our service do? How to summarize this? Well, it is a data management service that addresses the needs to collect, store, process, and analyze and visualize any kind of device data in just one service. That's already a major difference. We provide high-speed data ingestion and integrated data storage, support all kinds of data types and formats, provide different industry standards directly, custom code execution, integrate performance load balancing concept to prevent performance issues, white labeling and branding so that you can adapt the UI to your customer needs and your company logos, flexible dashboards and visualizations, configurable data queries to create an abstraction layers for your users, and last but not least, our so-called master data management to have an overview of your devices, all in one service. What do I want to point out with that again? Well, for us, the term data management service is not a database or a storage system or something like that. No, we want to provide you the full service solution, which means for us, this term stands also that you have a user management in it, that data privacy is secure, that a single sign-on works, that alerting is available, white labeling is available, everything that you need to manage your data and not just the storage. But at the same time, our offering is flexible and consists out of 5 modules, which can be used individually. So the world is not perfect, and I know many of you and other existing customers usually have some tools and some history, and they want to keep them. No worries, you can do that. You can connect all your existing tools and, for example, use the visualization that you might already have and just use us for storage, processing, and metadata management and keep the rest that you already use. Or you can also only use the visualization part. Everything is possible in this direction, and this is one of the additional key factors that we want to offer, a fully integratable service, so that you don't have to worry what to switch everything at one go. Again, to summarize the benefits a little, one single tool containing all the features that you need for your device data, which is highly customizable, flexible, so that you can really focus on your business case and that you can gain speed, time to market, which is one of the most success factors that there is in this business. And we offer this service as this solution as a software as a service. Why do we do that? Since our experience show software as a product, so licensed software, on-premise software is usually on long term far more expensive than a software service, which is very transparent and shows you the costs that being created with it directly, instead of doing it under the hood. You need man to do the infrastructure, maintenance, development, patches, and upgrades all on your own. This is all transparent on our side and included in the offering. But now I talked a lot about features and benefits of our service and so on. And so please keep those points a little bit in mind since they're important. And now I want to show you the reasons and the problems why it's so complicated to collect device vehicle data in the automotive area, and why our approach solves many of the issues that there exist. So the world we live in is not becoming easier, it's becoming more and more complex. And nowadays it's even more important to collect data, to keep track of what's going on with my products in the field. How did the users use them? What kind of issues exist? Otherwise, you lose track of them and you lose the chance to find errors. You lose the chance to optimize the product. You lose the chance to convince your customers that you have a good service. Well, but why is this the case? Why does the world become more complex, and why do I need data? And why do I need even more data? All of us know this somehow. So I will provide some general facts first. You all know that the amount of data worldwide, independent from the domain, independent from the device, is increasing exponentially. Why is this the case? Well, one driver is that the price per gigabyte is, of course, also increasing yearly by 30%. Mobile traffic costs are also decreasing on yearly base, which, of course, reduces the costs to use data. And this is one of the key factors and one of the main drivers. But this is, of course, not everything. And dependent on the domain, there are several other reasons, and especially for the automotive domain, I will try to point out one key factor, or multiple key factors. First of all, let's give you an overview of how does it look nowadays in a normal car. A typical car nowadays consists out of 100 ECUs or more from different brands, using different protocols, containing various signals and informations and models. And this is a real complex mess. But why? What is the source of this complexity? Why did it come to this? Well, you probably know you see it on the screen, every ECU is maybe supplied by a different supplier. Why is this the case? Each of these suppliers focus on delivering the best, most cost-efficient product on the market, and there are usually multiple suppliers for one specific part. So the OEM can choose for his use case, for his specific car, the best combination that he thinks is, and took it all into one car, which creates a very complicated environment since every car has a different setup from different suppliers. Of course, this is not the only driver. A car nowadays, in comparison to a car 30 years ago, has more functions and features. But the other reason is really just the cost-efficient drive. Let's see. You as an OEM or as a car manufacturer can choose nowadays from the suppliers, and of course will use the supplier instead of developing everything on your own to reduce the cost to the most efficient way. But back to the topic at hand. So we are not here today to solve this and to solve how to record this mess, how to actually get all the signals, which we can. We as ETAS provide a solution for this, but this is a complete different story on its own and would not be, and our webinar today would not have enough time to cover all of this. But if you're interested, of course, you can contact us. We will gladly show you this. For now, we will assume we found some magical way to record all of this and send the data into the cloud. Great. Now you could think, problem solved. I recorded everything. No. Now the problem actually starts. Why is this the case? The next challenge is right ahead. So you recorded all of this data, but in which kind of format? Every supplier, every ECU, and every protocol, there are different kinds of data formats in the field available. All of them are so-called standards, and all of them have their reasons, their pros, their cons. And they will exist even in a few years. They will not go away because they have been around since centuries and will be in the next centuries. But this creates a problem because all of these formats have been usually designed centuries ago. None of these formats was designed for analytics, data scientists, sending it to the cloud, mass data storage. They were all meant to provide direct analytics inside of the car or connected to the car, not a mass way to summarize the data, which you can already see on the left. In the end, if you look into a ChemTrace, it's a bunch of hex values that you get, which is non-human readable. And as an engineer, former engineer, and maybe some of you too, you might be able to read some of this. I can read some of this, but not fully. And most other people, developers and data scientists, cannot do anything with this because this is unfamiliar area for them. This is a mess in the end. So to summarize again, you have multiple data formats in the field. None of them is actually human readable. None of them is meant for data analytics or cloud usage, since those require readable structured data. And they are still heavily in use and cannot be replaced in the near future. But you think, okay, that's it? No, it gets even worse. Because looking at the format is one thing, no? But especially in the automotive domain, there exists two areas which are quite different in comparison when it comes to data, the so-called post-production and the pre-production, so the series car and the development car. Both of them are important, both of them are needed, and both of them are somehow connected. Because in the pre-production phase, you have a lot less amount of cars, like 10, 20, 30, but with an extreme high amount of data, several terabyte, maybe even petabyte. And those can be changed on demand, what you record there, and the frequency and everything. Everything needs to be done as fast as possible. But while on the other side, you have large amounts of vehicles and maybe only a few MB per month to reduce the costs, because of this area, it's post-production. The OEMs, your customers, our customers are very cost sensitive per vehicle. Every cent is basically too much. You will not get the chance to change the upload frequency, the communication and everything. But what both have still in common is that you get binary data, which is not human readable, just with different formats, and you have to handle them both. Makes it quite complicated and provides a lot of pressure for development teams and data scientists, since usually you would have to set up an own infrastructure to do that for each of those use cases. So now I try to explain to you what the problem is in the automotive environment with the different data amounts, different formats, and problems that there exist. And of course, I want to show you a solution for this, so that you learn how it's possible to share lots of data with different standard formats and handle all these different use cases. Of course, this is our solution, so you might have a different one, but we want to show you our experience. So how did we solve this problem? Well, many solutions on the market that are out there usually approach this in a different kind of way. They come with the approach to say, provide me the data in my format, convert it somehow before you sending it to me, and keep this and that kind of data size limits. Well, this can work, but it makes it also very complicated. And you now need a conversion engine before even sending the data, storing it, which is kind of strange because you already recorded the data. This makes it very hard for developers and data scientists to even start doing something, since they already have to find a way to convert something that they are not familiar with. And our experience and solution is a different one. We came up with the approach to say, if the teams and the customers and the users have so much problems in this regard, why don't we just accept everything that they have? So we came up with a different approach, the so-called Lambda storage approach, which means you record what you have and send this to us, no matter the format, no matter the size, no matter the frequency. Send what you have. We store this for you in a cost-efficient but still reliable object storage, and it's free object storage, before you can actually do something with it. Then the data is recorded in the cloud, and the first step has been already solved without you doing anything. And after this use case specific data has been stored in the cloud, it's far easier for your developers and data scientists to work with this data, since now they're in a familiar turf. They can use their existing libraries in the cloud on server side to extract this data. They can play around with this. They can optimize the extraction, the processing. They can deploy their models to transform the binary data, to transform the immense amount of data into a structured database standard, which can then be queried afterwards. Of course, we provide also predefined steps for multiple of those so-called formats, but all of this is extendable with custom code, with custom modules, so that you can deploy your use case. And then you have actual human-readable physical values, like temperature, speed, voltages, and other stuff. So again, how does it work? Each customer has its own processing pipeline, or multiple ones, where he can transform the incoming data using custom codes or predefined steps into a structured format. And of course, we support common programming languages like Python, Java, or other languages. And it's possible to deploy complex data analytics models in here. But this is also the main, one of the additional main benefits. You can even scale up this processing pipeline to your needs. So in the beginning, you usually start with only a few cars, less amount of data, and then you go higher. So you need a scalable infrastructure. You need a scalable solution, which we provide with this approach. You can define, or the system defines, depending on your settings, how much CPU, how much RAM do you need, how many instances, how fast does it need to work. This is also one of the main driving points to reduce costs even during the development phase and to match your project amount. We provide also, of course, a monitoring and notification system to keep track of this processing. So this overall enables you as a customer to optimize the data handling, store it efficiently, and without taking care of the underlying infrastructure, without being an IT expert, just using it and focusing on your business case. But now, let's say I have collected all this data, I processed this somehow, now I have readable signals. Yeah, that's nice. I want to work now with this. What do I do with that? How do I query this? after I have transformed the data. As a user, I want to see it now. I want visualizations, not just some numbers, because we humans are visual guys. We need pictures. For this, we provide a first-hand, also called query service, where you can extract the necessary signals, the parts that you want to visualize, and put into a dashboard. Why do we do this? Because, of course, you can just dump everything to the dashboard, but that gets slow. Remember, it can be terabyte of data, and you want to visualize this in a browser or in your local laptop, not a good idea. Therefore, extracting some of the signals is a key factor here to reduce the memory and performance footprint. After the extraction and the selection of the signals, then it's easy to visualize actually the data in a dashboard using widgets. And then you're basically done. You found a solution to collect the massive signals that you have in the field, process it, store it in a structured way, and query it, without actually setting up the whole infrastructure, without handling the database, without figuring out the performance. All of this is provided by us as a predefined solution. But now I have talked a lot and explained a lot theoretically and everything. And I'm also more of a guy to see it in real life, to have a feeling of the abstraction level, of the usability and everything. And I would like to visualize this and demonstrate this now to you in a live demo using our solution and approach, so that you also get a better feeling of how it looks and how it works for us. 1 second. So let's assume you already have an instance. I will not explain how to get one. There is a description for this. And let's assume you have a connected car, which I will be playing now manually. Of course, usually this is being done automatically and not like I'm doing it now manually. For now, I will just, for the demo, select a simple MDF measurement file collected from the field. And I want to know what's going on in there. Okay, I upload this. Nothing is happening. Why? Remember what I just said in the webinar? You need a processing pipeline. I did not yet configure one, so no processing is actually addressing this file, and therefore it's queued. I already created one, default one, which is stopped. It does not contain much, just our predefined steps to without much logic to extract the signals. So we will extract the signals into JSON readable format, and we will store it in a time series collection, which I will create a new one. Signals. Signals, time, the rest we will keep for now. Now I created a target to process the incoming data, parse the data, and store them. I save this and start it. What does happen technically? Well, this starts a Docker container directly for you in the cloud, a scalable one, containing your configuration or even maybe custom code if you have added it. And since it's a very complex service, it takes a few seconds to start up. You can actually see what is happening in our dev console. So the service is now online and pre-configured. And what happened now? Well, the file that I just uploaded has been processed, which means the binary information that was available in the file has now been transformed into readable signals. Great. And that was pretty easy. But now I want to visualize this. I want to see something because, yeah, these are nice values and everything, but what's happening here? Well, no worries. We got you. I have an empty dashboard. Let's start. I want a simple line chart. I select from the already pre-created query template the signals that I want to visualize. Beforehand, what is a query template? It's a pre-configured abstraction layer to extract the data, to filter out, for example, the time range that I want to have from data, and to do some pre-aggregations, average, and so on, to actually only get the signals, which we will not do today. For now, we just use the time range. And since the data is pretty old that I have to go, I don't know, 500 weeks back to get something. Save this. Now the backend already retrieved some of the signals to provide a pre-configuration. I can actually see them in here, all of them that are available. For the x-axis, I select time, and for the y-axis, I select distance. Oh, nothing much. Let's switch. At least the values are changing, but as you can see, it's just a small measurement file which not contains much. I can save this chart now, and it's now available for my users. I can extend this by making it filterable, by making it dynamically filterable. By if, for example, I would have multiple cars or time range, I can add a filter on top of this, combine this, and say, yeah, now the user can just select the signals that he wants, the cars that he needs, the time range, and whatever you want to do. And that's basically it. Now we're done. We collected the data, we stored it, processed it, and visualized it in just a few minutes, without handling infrastructure, without setting up code, without doing much. This works for 60 kilobyte. It also works for gigabytes and terabytes. I hope I could explain to you how our solution and approach works to handle mass amount of data. And now I would go into the Q&A part and would be happy to answer all of your questions, if you have some.